Good morning, everybody. Thank you for taking the time to join us this morning. My name is Cale Harbor. I'm the product manager of Advanced Control Solutions. I have co-presenting with me Mr. Bryant Henderson, our senior robotics engineer, and we're going to be walking you through a step-by-step application this morning on how to set up communications between a UR collaborative robot and a Cognex camera using the latest version of the new Cognex URCap. Before we get started with everybody, I do want to let you know that, as probably all of you have experienced at one point or another, we ran into some technical issues this morning. We had a computer die on us that we had to change last minute, and it died 12 minutes before our start time. So we are back up and running, but we're not quite as seamless from one slide to the next as we would like to be, and I do apologize for that up front, but it won't hurt the quality of the content that we're going to be getting out to you. So as we go through, I'm going to be keeping an eye on the chat window. As you have questions that come up, please feel free to post them in the chat room, and I will be monitoring that. We will make sure to answer them at the end of the session or wherever we have a break that is appropriate. So that being said, I'm now going to turn this over to Brian.
Hey, good morning, guys. I appreciate everyone's time this morning. I appreciate the introduction, Cale. Like Cale mentioned, I am our senior robotics engineer here at ACS. I've been working with UR and Cognex systems for a few years now. And today our end goal is going to be to show how to configure a universal robot with vision guidance using the Cognex URCap. At any point, if there are any questions, please feel free to post them to the chat room, and we'll be sure to get them addressed, because at the end of the day, this session is meant to educate you guys. So just a quick introduction and overview of the equipment and software that we're going to be using here. So we are set up currently with a UR3E. This same process and configuration would apply to any model robot, the 3, the 5, the 10, the 16, and this URCap functionality is available for both CB and E-series robots. All that we have communicating between the two robots is an Ethernet switch, so they are just on the same network, passing data back and forth over Ethernet. The software we are going to be using is the latest and greatest Polyscope UR interface software 5.8, as well as the latest and greatest In-Sight Explorer software version 5.9. Just a quick note, all of the URCap configuration in In-Sight Explorer is going to be done through the Easy Builder interface. So it is more of a wizardized, streamlined setup process. Finally, the last software piece we're going to be utilizing here is the Cognex URCap. If you're unfamiliar with the URCap terminology, this stands for UR capabilities, and they are certified drivers from third-party vendors to allow easier configuration of complex applications. In this case, is going to be vision guidance. The real point there is these add-ons are tried, tested, and approved, just like an app would be on the App Store by Apple, to assist in your setup process. And just at a quick overview level, some of the theories that we're going to be using here are a hand-eye calibration. This refers to the process where the robot is moving throughout the field of view automatically, and the camera is finding the robot. That'll make more sense once we go into the live demo. We are also using the concept of calibration, so where the camera sees all of its objects in a 2D pixel coordinate system, we are translating these two-dimensional pixel coordinates into 6-dimensional robot coordinates. And then finally, to get those coordinates in, we are going to be using Ethernet communication. So first of all, the first step that you're going to have to install is all of the software. We are going to go under the assumption that you already have In-Sight Explorer downloaded and you already have the most current robot software. To run the, or to download the URCap, you could just Google Cognex URCap, and you can download the URCap software here. And also, we could download the user manual, which is essentially a step-by-step process of what we're going to be walking through today, if you guys have any questions. Once we go over to the robot interface, what I have here is our UR3E teach pendant. I know it's a little bit delayed, but you should be able to see my cursor. To install the URCap, you'll just come over here to the hamburger menu in the upper right. You'll click on Settings, come over here to System, go into URCaps, and hit the plus button. You would need to insert a USB disk into the controller or into the USB hub in the upper right hand corner of the teach pendant. Select the URCap file there and then restart the robot, and you should see an indication like this that shows the URCap name, the developer, and now we have this driver installed on the robot software. So coming back to our In-Sight Explorer interface, we are first going to need to get connected to our camera. So we'll start with a blank Easy Builder job. I see my camera down here is URCap _ demo. This camera will need to be on the same network as our robot. So in order to see what our current IP address is, I could come in here to Sensor, Settings, and see the IP address is 192.168.1.100. So we are just going to need to ensure that our robot matches that IP address. So coming back over here to our robot interface, I can again go back to the hamburger menu in the upper right and click on Settings. Under System, you can now go into Network, and you can see the static address that we have configured there and the indication that the network is connected. So we should be communicating over our Ethernet connections, and we are good to start programming. So there's really two steps to configuring vision guidance. The first step being calibration, the second step being pattern recognition and communication. So there's going to be two separate jobs. One job that is going to be dedicated to calibration, and that's going to be the process of the hand-eye movements of the robot moving in front of the camera's field of view and sending those coordinates to then create a file that translates our 2D camera coordinates to 6-dimensional robot coordinates. So first of all, we are connected now. We can go to set up our image. In order to configure this, I'll go to my live video. Looks fairly dark, so I will bump up the exposure. We can remove the film strip so we get a larger image. I'll then go in here and set the trigger mode to manual. Another quick note is that all of the steps that I'm going to be going through here are all enumerated in a little bit more detail in the manual for configuring the URCap that I showed you could download online earlier. So feel free to know that this is there to reference. And if you also have any questions, please feel free to let us know. So we've adjusted our exposure so that we can see the part. We've changed our trigger mode to manual. So now what we're going to need to do is train a pattern on the tip of the robot tool center point. So I will come back over here to the robot interface. I can power on the robot. I can start the robot. One prerequisite is that you have a correctly defined tool center point. So if I come over here to my installation tab, you can see the TCP is defined here. That is just a direct Z offset from the gripper. To just show you the setup that we're working with here, this is a live image of our robot. I have a free drive switch in right here. And so the tool center point is just the direct tip of where you're making contact with your part. So in this case, it's just the tip of our fingertips. I have this free drive switch that is tied to the robot controller so that when the switch is on, I can move the robot, and when it is off, I can lock it in place. So what we're first going to need to do is hold our part in the gripper so that we can detect our TCP. So I will come over here to my robot interface, and I will turn my free drive off. And first I just need to activate the gripper because we just powered on. So I'll hit the button to activate. I want to slow down the speed, and I'm just going to hold this part in the gripper, and we have it in the gripper now. So I will turn on my free drive again and position my robot in the field of view. So we're about flush with the field of view right now. If you can see, we're about a fist height below where this 8020 is on our setup. So I'll turn off my free drive, and now that we have the part in the field of view, we can come back over here to In-Sight Explorer and configure our vision guidance. So if I trigger the camera, I should see the part there. So now we need to add a location tool. So just working down the Easy Builder menus, I'm going to look for a pattern. So I'm just going to click Pattern and add a pattern. Our search region, we want to be the whole field of view, so we're going to leave that the same. And I am just going to align the model with the pattern in our field of view. So if I hit OK, I can see that the pattern is now found. So one quick note is that it is extremely important that the location of the pattern tool is directly where your tool center point is defined in your robot interface. So you can see here it's a few centimeters, probably not centimeters, pixels would be the better term. It's a few pixels below the tip of the tool. So I can come down here to the settings of my pattern tool, And if I click on the vertical offset, that is going down. We just want to move it up roughly to be directly where our tool center point is. That looks about good. So now we have found our tool center point. We need to now link this inspection tool to a robot guidance tool. So I'll click on inspect part. I can come down here to calibration tools and click robot. After I double click this calibration tool, you can see in the directions I need to select a smart feature. That smart feature is just going to be my pattern. So I'm just going to click on that pattern there. If I zoom in a little bit, that will be a little bit easier. So I click on that pattern, and now our calibration tool is linked to our pattern tool. So we are configured for our calibration job here on the camera. So now I'll save this as calib_webinar. Coming back in here to our calibration tool, you can see the name of the calibration file that is going to be generated. This is that file that you will reference to translate the 2D pixel coordinates to the 6-dimensional robot coordinates. So I'll just call this webinar _URCap, and then we can append the date and time if we wanted to. We don't really need to do that here, so it would just be named webinar URCap calibration. Okay, so we are set up on our camera to find our tool center point. Now we need to configure the robot for our field of view. So if I come back over to my robot interface, I can come into the installation tab, select URCaps. Here's where we would input the IP address of our camera. You can see that it is connected to the camera right here, and we need to set the dimensions of our field of view. The way that you do this, you can see in this diagram on the screen, is you set 2 points being the width and then 1 point being the height. So I can click on set point, and I will jog the robot relative to the base, and I'm going to go to this front left corner of my field of view. So to ensure I can find the pattern at that point, I could come over here to the camera interface and select it on repeating trigger, and we're about close to the edge of the field of view there. So I can come over here to the robot interface again and select OK. Now we need to set our second point. So I can jog the robot forward in my X plus. Again, coming back over here to the inside interface to ensure we are finding the pattern. We can see it there. So it is generated. So I will then go back to my robot interface and confirm that point. And finally, we need to teach the width. So if I come back here to the camera, and that's about at the edge of our field of view there. So coming back to the robot interface, Once you see that all those 3 points have been set, you'll get a green check mark by each of the 3 points. So now we just need to ensure that the camera is online. So I will take it out of repeating trigger mode, put the camera online. Again, remember the step earlier of configuring the image trigger mode to manual. If it is not in manual, you will not generate the calibration file. But as I come over here to my robot interface, now that our camera is online, I can click on Start Calibration. And coming over here to the camera, you can see the robot is moving to these positions in the field of view and automatically generating the camera file, or the calibration file, excuse me. So just to get a quick image of what that looks like, I believe there's 25 different positions that the robot is generating based off the field of view coordinates that you would set. So just finished, and if we come back over here to the robot interface, we will see that a calibration has now finished. So I can just hit stop program, and now we have that generated calibration file. So step 1 is done. Now it is step 2 to generate our robot guidance file and program. So I can take the camera offline. We'll save our calibration job, and we'll just open up a new job and clear all data from the current job. And we'll save this job as guidance_webinar. Oops. So we'll do the same process here of setting up our image. So I can come in here to our live view. In this example, we're just going to be picking and placing a block. So I have that block in the field of view. Looks like we'll need to bump our exposure up a little bit to get a clear view of that block. That looks about good. Again, change the trigger mode to manual. And then in this setup image calibration type box, we can then select and import calibration. See some of the other calibration options that Cognex has available here, but we're going to just import a calibration. We can come down here to our file name, and as we scroll down, we see a few of the other calibrations that were generated, but we have the one webinar URCap.cxt. The robot's units are in millimeters, so we do not need to change that box. So now I can just go into our location part tool. We will set up a pattern tool again, just looking at this block. And then hit OK. One thing I will change in the settings of our pattern tool, you see the rotation tolerance here is 15. We want to pick it up if it's anywhere plus or minus 180 degrees rotated. So I'm going to change that real quickly. So coming down to inspect part, we can go into Math and Logic tools and add in a robot guidance tool. Our robot guidance tool, again, is going to be linked to our pattern. If you're having issues selecting it, you can just zoom in. See some of the other circles we can find here, because this plastic bottom of the table has holes drilled into it, and the camera is seeing through those holes and finding circles, and that's technically a smart feature, but just be aware that you want to link it to your pattern. So we have our pattern and our robot guidance configured. So now our camera job is good to deploy. So I will go online, and now our camera is ready to communicate and send coordinates to the robot. So we need to program the robot now. So coming back to the robot interface, we will go into program, and we're just looking at an empty program right now. So I just want to move initially to a waypoint. So I'll free drive the robot and set up a waypoint. Yeah, face it forward right there, and undo the free drive. Sorry if you guys couldn't see that. We will set that waypoint right there, and this is where we will come to trigger the camera. Right now we've got a part in our gripper. Maybe we want to make sure that the gripper is open. At this point, I'll just add in a gripper, edit action, open with maximum speed. From this point, we then want to go in here to our URCaps, and we want to add in a Cognex camera pose. So first of all, we need to set our reference position. This reference position is the position at where the pattern was initially taught. So we taught our pattern right there, and we haven't moved this block in the field of view. So what I'm going to do is I'm going to set this reference position directly above our block. Using the Align tool on the robot interface, I can turn off my free drive, align to ensure I'm perpendicular. Looks like I need to rotate wrist 3 just a little bit and make sure I'm centered on the part, but that looks good. Make sure the Z height is about there and hit OK. So you see we automatically generate this movement to where our position is. So we probably want to move to an approach position before this, so I can add in a variable to call it approach. We'll call this APP, and this is going to equal pose add, and we're just going to add 5 centimeters to the Cognex result position. So I'm just going to select the Cognex result, and then I'll put in a blank pose here just with 5 centimeters. So 0 in the X, 0 in the Y, 0.05, and 0 in the RX, RY, and RZ. So then finally, we just need another waypoint, and I will select variable position and move to the approach. So now we have an approach, a result position. Here we probably want to close the gripper. And I can hit a close command, save action. We then could move back up to our approach, so we just go straight up after we pick up the part. And Then finally, we'll have it drop off the part somewhere over here to me, and just set our waypoint 2 right here. And then we can copy our gripper open command and put it there. So now this is what happens when the job passes. When the job fails, I'll just add in a pop-up that says fail. And when there's no response, we'll say no response. Okay, so we can make this a joint move just so it's a little smoother motion. We can save the robot program as webinar. And we should be good to run our program. So I will open up my gripper, put the part in the field of view. We will again ensure that the camera is online. Camera is online. And now we can go to run the program. There we go. So what we need to add into our robot program, if we come back over here to the robot interface, is a wait command, because the camera is being triggered before I had time to put the part back. So I'll add in a wait for, we'll say 3 seconds. So if I play the robot program and come back over here so you guys can see it. The robot then goes, picks the part from there, and it hands off. So you can put the part back down here again, run the program, and once we go in to see our camera interface here in just a second, we can see the coordinates that it was found at. So if I come back over here to the camera interface, you can see our coordinates and our angle that we were found at there. If I come back over here to the robot interface, we can see in our variables where our approach position is. So these are the coordinates that are being sent over via the calibration tool that is happening there. So again, I apologize for the quick disconnect in getting the final showcase up and running. But this was just a very quick demo to show a really basic robot program that you can see here in 19 lines to approach a position and go and pick the part from there. So what I will do is go back to my application view, and now we can open up the chat room for any questions that anyone may have.
Right now, the chat room is clean, Brian. I'm not seeing anybody else posted anything at this point. If someone does have a chat, let me know. Oh, here we go. To manage, let's see, to manage different part shapes like a product changeover, is it possible to call up the files for robot and camera from the PLC?
So the question we had is it possible to call up program changes for a file from a PLC on the camera and the robot? The answer is yes, you can do this. The most common way that I have seen this being done is through shift registers. So the robot is simply looking at an integer value that is sent over from the PLC, 1 through, call it 200. Maybe you've got 200 different programs. Depending on that integer that is sent over, you are then going to call up that specific program. Similar on the camera end, you could do a job state. So based off of whatever that number is that's sent over from the PLC, we make certain location tools active, and we make certain location tools inactive. So that handshaking is something that's fairly common in industrial applications.
Another question we had is, do you have to have a PC for communication, or can you direct link the camera to the robot control?
So the question was, do you need a PC in between to direct link the camera and the robot? No, you do not. So you would need a PC to initially configure the camera, to run In-Sight Explorer, to calibrate and run the location tools on the job. But once the camera is configured and programmed, you would not need a dedicated PC for that camera, and it would just be communicating directly to the robot.
Another question we had, why aren't we using a network trigger versus a manual trigger, since we are communicating via Ethernet?
So the network trigger is happening. That is built into this Cognex result node here in the URCap. So a portion of this URCap node that was developed is the network trigger. So we have deployed applications with a discrete trigger. It really just depends on the environment that you want to run in. But yeah, that network trigger hook over Ethernet is happening here. It's just kind of hidden behind the scenes.
That's all the questions we have in the chat room right now. If anybody else has another one, please post it. We'll give it just a couple more seconds. Will you close this up?
Yeah, I appreciate everyone's time today, and if I can go back to my PowerPoint, I will put up my contact information here. If anyone has any questions, additional applications that would potentially be possible, I'd be happy to have a discussion or point you to the right representative to get your questions answered. But all in all, I hope today was helpful in showing how you could configure basic vision guidance in a couple hours, whereas in years past it'd take a couple days or likely weeks. So again, thanks everyone for their time, and hope everyone has a good day.